The third group follows a different path. Instead of abandoning the classic 5-volt electrical environment, these boards preserve it while changing the processor underneath and extending what the familiar forms can do. Nano Every and UNO Wi-Fi Rev2 use the newer 8-bit Ch.1 4809, UNO R4 Minima, UNO R4 Wi-Fi, and Nano R4 move into the 32-bit Renesas RA4M1. Their shapes remain familiar. Many older modules can still meet their GPIO at 5 volts, yet the registers, timers, interrupt systems, current limits, memory maps, USB behavior, and library assumptions are no longer those of the ATmega 328p. This is why voltage compatibility and software compatibility must be separated. A shield may fit, its signal levels may be safe, a low-level AVR library may still fail. Nano Every offers more room while remaining 8-bit. UNO Wi-Fi Rev2 adds radio, motion sensing, and secure hardware. The R4 family adds more memory, finer ADC resolution, DAC, RTC, CAN, and native USB, with wireless features on the Wi-Fi model. Stay with the distinction, familiar contact, a different interior answering below. This video shows how Arduino can modernize the system without forcing every project into a 3.3-volt world, and why that 5-volt continuity can remain a serious engineering advantage. Arduino Nano Every belongs with the newer boards, even though an 8-bit AVR still rests at its center. It was created as a modern evolution of the classic Nano, the same narrow form, the same breadboard-friendly rhythm, and 5-volt compatibility, but with more memory, a newer peripheral system, and a controller designed after the ATmega 328 generation. Choose it for compact robots, wearable experiments, classroom sets, musical controllers, sensor nodes, and embedded systems that need more room than the classic Nano can offer without moving into a 32-bit architecture. It can sit directly inside a breadboard, or be soldered onto a custom PCB through castellated edges, allowing the controller to disappear more completely into the finished design. But the familiar pin arrangement should not create a false promise. ATmega 4809 registers, timers, ports, and interrupt routing differ from those of the ATmega 328p. Portable Arduino sketches often move easily. Low-level AVR libraries may need explicit support. Versions with or without headers let the same board serve quick experiments or become a low-profile part of a custom assembly. So let the familiar body draw you closer. Notice the new interior and let the difference settle. Nano Every preserves the approachable 5-volt surface of the classic Nano, while quietly introducing a newer kind of AVR underneath. At the center of Nano Every is the 8-bit ATmega 4809 AVR. The chip can run at up to 20 MHz, but Arduino's official Mega AVR platform currently configures Nano Every for 16 MHz. Using 20 requires a matching clock and platform configuration, so millis, delays, serial timing, and other frequency-dependent code remain correct. The board uses 5-volt logic and provides 48 kilobytes of flash, 6 kilobytes of SRAM, and 256 bytes of EEPROM. Its nano headers expose the familiar digital and analog positions, including 8 analog-capable inputs and 5 PWM outputs on D3, D5, D6, D9, and D10. UART, SPI, and I2C are available, and the newer AVR architecture can route external interrupts across its general-purpose pins. A separate ATSAMD11D14A Cortex-M0 Plus processor implements the USB to serial bridge and handles firmware upload to the ATmega 4809 through UPDI. Power can enter through micro USB, VUSB, or VIN, with VIN supporting inputs up to 21 volts within the documented operating range. Keep the two controllers distinct. One runs the sketch, one opens the USB path, and the signal moves between them. The board remains compact and 5-volt friendly, while the newer AVR gives it more working space and a more flexible internal structure beneath the surface. Arduino UNO Wi-Fi Rev2 keeps the recognizable UNO outline while shifting the project toward connected projects. Choose it when you want an UNO-sized board to join a Wi-Fi network, communicate through Bluetooth Low Energy, measure motion, or connect securely to cloud services without stacking separate radio and sensor modules. It is useful for home monitoring, connected controls, mobile interaction, small IoT gateways, remote data collection, and prototypes that need a familiar physical layout with built-in wireless. The board also carries an inertial measurement unit, an accelerometer, and gyroscope able to sense movement and rotation. A secure element can protect cryptographic keys used in authenticated communication, but the familiar UNO shape can hide an important change. This is not an ATmega 328P board. Its main controller is the newer ATmega 4809. The registers, timer architecture, interrupt routing, and some low-level details differ. A portable sketch may feel immediately at home. A library that reaches directly into UNO Rev3 hardware may not. So let the outline welcome you, without letting it make promises the silicon did not give. Look beneath the label and let the real architecture appear. The board is 5-volt and physically familiar, yet internally it belongs to a newer AVR generation designed for a different kind of connected response. The UNO Wi-Fi Rev2 uses the 8-bit ATmega 4809 as its main microcontroller and operates with 5-volt logic. Arduino's official Mega AVR platform configures this board to run at 16 MHz. The ATmega 4809 silicon supports up to 20 MHz, but reaching it requires a core and clock configuration that changes the real hardware clock and keeps millis, delays, serial timing, and other frequency-dependent code consistent. It contains 48 kilobytes of flash, 6 kilobytes of SRAM, and 256 bytes of EEPROM. The board preserves 14 digital I/O positions and 6 analog inputs in the UNO form factor, with PWM available on selected digital pins. Wireless communication comes from a NINA W102 module, providing 2.4 GHz Wi-Fi and Bluetooth Low Energy, an LSM6DS3 TR6-axis IMU adds acceleration and angular rate sensing. An ATECC608 secure element supports protected keys and cryptographic operations. UART, SPI, and I2C remain available, but their implementation beneath the Arduino API belongs to the 8MB 4809 peripheral system rather than the 8MB 328P. Hold the distinction. 5 volts, a newer AVR pulse beneath. The board can meet many classic electrical accessories, yet software that depends on old-timer registers, port names, or exact interrupt behavior must be checked before the familiar headers are trusted. Arduino UNO R4 Minima is a modern answer for someone who wants the approachable UNO form without wireless hardware. It keeps the large, readable headers and 5-volt electrical environment of classic UNO projects, while replacing the old 8-bit controller with a faster 32-bit device. Choose it for education, general prototyping, control systems, signal processing, projects that need more memory, native USB devices, a real analog output, a real-time clock, or CAN communication through an external transceiver. The Minima is deliberately restrained. No Wi-Fi module, no LED matrix, no second wireless processor. That absence can be useful. There are fewer subsystems to configure, fewer radio concerns, and a cleaner path between the sketch and the main RA4M1 microcontroller. Many UNO shields can connect physically and electrically because the board uses 5-volt GPIO, but software compatibility is not guaranteed. A library that assumes ATEMGA 328P registers, AVR timers, or AVR assembly may fail, even though the shield fits perfectly. So let the familiar outline bring comfort without letting it hide the change. Keep the surface, replace the interior, let familiarity and change meet. The R4 Minima is not a faster UNO Rev2 in every detail. It is a new architecture wearing a form designed to make that transition gentler. The UNO R4 Minima uses the Renesas RA4 M1, a 32-bit ARM Cortex-M4 microcontroller with an FPU running at 48 MHz. Its GPIO operates at 5 volts, but each pin should be limited to 8 milliamps. 5-volt compatibility does not guarantee classic UNO drive strength. It provides 14 digital I/O pins, 6 PWM outputs, and 6 analog inputs configurable up to 14-bit resolution. Arduino analog read begins at 10 bits until another resolution is selected. A 0 can also act as a true DAC output with up to 12-bit resolution. Memory includes 256 kilobytes of flash, 32 kilobytes of SRAM, and 8 kilobytes of data flash for EEPROM-style storage. The controller adds a real-time clock, capacitive touch hardware, an operational amplifier, native USB with HDD capability, and a CAN controller that requires an external transceiver. Communication includes UART, SPI, and I2C. USB-C replaces the older Type B connector. VIN and the barrel jack accept 6 to 24 volts, while GPIO current limits remain strict. Hold the comparison: 5 volts, 32 bits, 1 precise meeting point. The labels remain familiar. The memory expands, the clock triples, Yet the RA4M1's peripherals and registers form a different internal language. One portable Arduino code can enter more easily than old AVR-specific libraries. Arduino UNO R4 WiFi takes the same RA4M1 foundation and surrounds it with a second programmable processor for wireless communication. Choose it when a project needs the approachable UNO form, 5-volt headers, modern 32-bit control, Wi-Fi, Bluetooth Low Energy, and a visual surface built into the board. The 12x8 LED matrix can display symbols, scrolling text, status patterns, simple animations, and tiny games without an external display. The Quick Connector offers a quick 3.3-volt I2C path to compatible modules. Wireless connectivity supports cloud dashboards, remote sensors, connected controls, educational IoT systems, and prototypes that need local interaction and network communication. The ESP32S3 module can be accessed directly by advanced users, but two processors create two layers. The RA4M1 controls the ordinary UNO headers and executes the main sketch. The ESP32S3 provides the radio subsystem and participates in USB routing. Their voltages differ internally, and level translation keeps the relationship safe. The board makes that complexity feel smooth. Two systems, one surface, one carefully shared response. Yet libraries, firmware versions, wireless stacks, and the division of responsibilities still matter beneath the gentle outline. Choose it when connectivity is part of the design, not merely an unused promise glowing on the board. The UNO R4 WiFi uses the same 48 MHz Renesas RA4M1 as the Minima. The main controller is a 32-bit ARM Cortex-M4 with a floating point unit, 256 kilobytes of flash, 32 kilobytes of SRAM, and 8 kilobytes of data flash for EEPROM-style storage. Its exposed GPIO operates at 5 volts, but each RA4M1 pin should be limited to 8 milliamps. It provides 14 digital I/O pins, 6 PWM outputs, and 6 analog inputs configurable up to 14 bits. Arduino analog read defaults to 10 bits until another resolution is selected. A 0 can produce a true DAC output with up to 12-bit resolution. The RA4M1 also includes an RTC, native USB hide, an operational amplifier, and a CAN controller requiring an external transceiver. Wireless communication is handled by an ESP32S3 Mini 1 module, operating internally at 3.3 volts and providing 2.4 GHz Wi-Fi plus Bluetooth 5 low energy. The board adds a 12x8 red LED matrix and a QWiC I2C connector. USB-C is used for power, programming, and communication. The familiar UNO headers remain 5-volt, while the ESP module lives behind level translation at 3.3 volts. Keep that boundary visible: one board, 2 voltages, one discipline boundary. From the outside, the system feels unified. Inside, 2 processors exchange data carefully, each prepared for a different kind of response. Arduino Nano R4 belongs with the new boards and brings the Renesas architecture of the UNO R4 family into the smaller Nano form. Choose it when a project needs 5-volt compatibility, more memory, modern analog features, native USB, and compact dimensions, without requiring Wi-Fi or Bluetooth. It suits small automation controllers, portable instruments, signal processing experiments, data loggers, sensor interfaces, compact robots, and prototypes that may later move on to a custom PCB. The board preserves the familiar Nano arrangement, yet adds a Ch.1 connector for quick 3.3-volt I2C expansion. A real-time clock can keep date and time. A true DAC can create a varying analog voltage. An internal operational amplifier can condition signals. CAN support opens a path toward automotive and industrial communication when an external transceiver is added. This is not simply a classic Nano made faster. The RA4M1 uses a different processor architecture, peripheral layout, interrupt system, and memory model. Portable Arduino code may cross smoothly. Direct 8-mega register code will not. Let the narrow outline remain familiar. Feel the architecture change beneath it. Slowly. Nano R4 keeps the 5-volt contact many older circuits expect, while allowing a much wider 32-bit system to unfold inside the same compact space. Nano R4 uses the Renesas RA4M1, a 32-bit ARM Cortex-M4 processor with a floating point unit running at 48 MHz. It provides 256 kilobytes of flash, 32 kilobytes of SRAM, and 8 kilobytes of data flash used for EEPROM-style storage. The main breakout pins operate at 5 volts. The Ch.1 connector operates at 3.3 volts through level translation. The board presents 14 standard digital positions, 8 analog channels, 6 PWM outputs, UART, SPI, 2 I2C buses, native USB through USB-C, an RTC, an operational amplifier, and a CAN controller that requires an external transceiver. The ADC hardware supports up to 14-bit resolution, but analog read defaults to 10 bits for Arduino compatibility until analog read resolution selects 12 or 14 bits. A 0 can provide a true DAC output with up to 12-bit resolution. VIN accepts approximately 6 to 21 volts. The RA4M1 GPIO pins should be limited to 8 mA each, an important difference from assumptions carried over from some older boards. Keep voltage and current separate. 5 volts does not mean unlimited strength, only a familiar level. Nano R4 offers the electrical familiarity of a 5-volt Nano, but every connection still asks for the current limits, peripheral mapping, and software expectations of its newer Renesas heart. Now let the modern 5-volt group arrange itself, slowly, until familiar voltage and new architecture can be held together. Nano Every keeps the compact Nano form and the 8-bit AVR model, while at Mega 4809 gives it more memory and a newer peripheral system. UNO WiFi Rev2 uses the same AVR generation, adding Wi-Fi, BLE, motion sensing, and secure hardware. UNO R4 Minima moves into the 32-bit RA4M1 without radio complexity. UNO R4 WiFi surrounds that controller with an ESP32S3, wireless communication, and an LED matrix. Nano R4 takes the RA4M1 idea inward, tighter, breadboard friendly, with 5-volt GPIO. 5 volts remains familiar. Current limits do not. The headers may welcome old modules. The registers may reject old assumptions. Let both truths touch without confusion. Familiar outside, new pulse within. Same level at the pin, a different rhythm under the skin. Choose every when compact 8-bit simplicity needs room. Wi-Fi Rev2 fits connected AVR projects. R4 Minima fits clean modern control. R4 Wi-Fi fits networked visual projects. Nano R4 brings Renesas capability closer. And after these boards, the scale opens wider. 2 cores, external memory, cameras, displays, audio, networking. Giga and Portenta wait in the next video. Powerful enough to ask whether the project truly needs that depth.